Welcome to this a video on integration. We're going to perform some iterated integral here, and this involves a trigonometric function, sine of x to the power of n. And to get started here, I'll do a little trick here. So on my solution bit here, I am supposed to integrate sine of x to the power of n dx, and this one can also be rewritten as integral of sine of x to the power of n minus 1 then sine of x dx. That's the trick I want to use here. You notice that according to the laws of indices, this is to the power of 1, so it will now make a sine to power 0 when you multiply here, and anything to the power of 0 is 1, so you'll get back to the sine of x to the power of n. That's cool. Now the reason as to why I want to invoke that trick is simply because I want to use integration by part here, and I want to let my u to be sine of x n minus 1, and so du over dx is n minus 1 sine of n minus 2. Of course, now it's sine of x to the power of n minus 2. Then we differentiate sine, we get cosine of x, right? So my dv is equals to, sine of x dx. So v is nothing but cosine of x negative. All right, so when now I use my integration by part formula, I am supposed to have now my integral to be uv. So my u is sine of x to the power of n minus 1. I multiply by v, so the negative comes in front. Then we have cosine of x, then minus integral of v du dx. So my n minus 1 comes as a constant outside the integral symbol, and then I have my sine of n minus 2 x. That's what du dx x. And when we have the cosine of x now with a negative, changes this to positive, and I have now cosine of x here dx. All right, so this part here is for du dx, and this n minus 1 which came onto the front is after we differentiated this part here, and this cosine of x is coming from v. But now because here we are supposed to have a negative, this negative and the negative in the formula cancels to make a positive. Okay, so we have this part here that we need to simplify. So we have minus sine of x to the power of n minus 1 plus n minus 1 integral. Of course, now this will make cosine squared of x, and using the handy basic trig identity, we can rewrite this one as follows. Integral, here we have sine of x to the power of n minus 2. Then instead of writing cosine, we write 1 minus sine square of x, then dx, and we simplify. Still working on the integral. So we are going to have two separate integrals here. So we integrate this. We have the integral as sine of x to the power of n minus 2 dx, and then minus n minus 1. I'm now distributing integral of, this times that becomes sine of x to the power of n dx. And you notice that this part here is more or less like what we were given here to integrate, and so you allow me to rewrite this one as let integral of sine of x to the power of n dx be equal to I sub n. Okay, so this is my I sub n. What I'm trying to do is this integral, and then we equate to minus sine of x n minus 1, then cosine of x plus n minus 1 integral of sine of x to the power of n minus 2 dx minus n minus 1. Now, instead of n minus 1 integral sine of x to the power of n dx, I write I sub n, because I sub n is equivalent to, integral of sine of x to the power of n, right? So I can now put the like terms together. So I have my I sub n is equals to minus sine of x n minus 1 cosine of x plus n minus 1 integral of sine of n, x n minus 2 dx, then minus n minus 1 I sub n. So we can put these like terms together. So I'm going to add into bracket n minus 1 I sub n to both sides, and I'm going to have I sub n plus n minus 1 I sub n is equals to minus sine of n minus 1 as the power, sine of x n minus 1 as the power cosine of x, plus n minus 1. And I want to also change this one a little bit. So using the recursion relation, if this is sine of x to power n is I sub n, then when you have n minus 2 here, we can call it I n minus 2. So we have to rewrite this one as I sub n plus n minus 1 I sub n is equals to minus sine of n minus 1 x cosine of x, and instead of writing now integral of sine of x n minus 2 as the power, we write now I n minus 2. All right, so here we have plus n minus 1 I sub n minus 2. All right, so now from here we can now simplify, factor n sub 1 out, it's common, so we have 1 plus n minus 1 equals to minus sine of n minus 1 x cosine of x plus n minus 1 I sub n minus 2. Okay, I hope that makes sense. So now we simplify here and we get, creating space here, so we have I sub n times n is equals to minus n sine of x n minus 1 cosine of x plus n minus 1 I sub n minus 2. So you can now divide by n both sides, so that we already now have what our I sub n is. And so my I sub n is this is not there, so we have minus sine of n minus 1 cosine of x plus n minus 1 I n minus 2, and so this is divide by n, and so if you simplify this, you're going to have now your integral coming out clearly as you have I sub n is equals to minus sine of n minus 1 x cosine of x over n plus n minus 1 over n minus 2. So that's the reduction formula symbol for that, and it makes sense. All right, so if you're given, let's say for example you're told to integrate integral of sine square of x dx, it's very simple. The value of n here is 2, and so it's like you're going to substitute 2 in this, and you determine your integral. And so this one can be, that's like I sub 2, and so it's given by minus sine of 2 minus 1 x cosine of x divided by 2, and plus 2 minus 1 over 2, and then integral of the integral of n. This is like integral of I sub 0, right? So if you do that, this simplifies into you have minus sine of x cosine of x and over 2, and then plus this is like a half, then this is like integral of sine of x to the power of 0 dx, and this gives us minus sine of x cosine of x over 2 plus integral of this is like any number raised to power 0 is a 1, so it's like we are taking the integral of 1, and that gives us a half x. Okay, and this can be written as a half x minus a half sine x cosine of x, which is also known as a half minus this is like sine of 2x divided by 4. All right, yeah, and that makes sense, plus a constant of integration. And so this reduction of order integration is very important when you have powers of n, and you really want to to perform that integral. And sometimes it can be very easy when you know the recursive form of that integral. And that's how it's done. Thank you.